So, cutoff is here. Indicate that as 10 volts. Saturation, let's show it here. How much? 10 milliamps. Write down SAT here, write down cutoff here. Okay, and then draw a straight line like this. And then we're going to show on that straight line where this circuit is operating at. So basically what I've shown there are the two extreme points. Now on that circuit, I'm applying a little bit of base current. How much? 43 microamps. That's causing 6.45 milliamps of current to flow this way, which is causing a voltage of 3.55 volts at the transistor. So it's not 0, it's not 10, but it's 3.55. So where do I show the 3.55? Right along the x-axis here. So 10 volts is there. Half of 10 is how much? 5. 3.55 is where? 1, 2, 3, 4, 5. So 3.55 is right about here. So indicate 3.55 like this. And then what I do is I take this point and go up and hit the line and then go across. And that is my IC value of 6.45 milliamps. At this point, I call it the Q point. And I indicate that as a coordinate of X and Y values. The X value is 3.55 volts. The Y value is 6.45 milliamps. That's my circuit and how it's behaving. Okay? It's not fully open. It's not fully closed. It's partially closed with a voltage of 3.55 across it. If I was to change this value of RB to another value, it means that I'm changing the tap. So that might change the value of the collector, which will shift my Q point. It might get closer to saturation. It might get closer to cutoff. That's how you design transistor circuits. Make sense? So there's one last calculation I have to do. PD. PD. What's PD? Power. Power dissipated. Power, we know, what's the formula for power? V times I. In a transistor, what is the V volt value? The voltage from the collector to the emitter. How much? 3.55. The current. What is the current in the transistor? IC. How much? 6.45. What's 3.55 times 6.45 milli? What do you get?
22.9 milliwatts.
22.9 milliwatts. So this circuit, in this circuit, my transistor is dissipating. It's got about that much power wattage on it. That's how hot the the transistor is becoming. So, go to the appendix. Go to page 13. On page 13, we have the value of power in the table. P total, total power dissipation. For this model of transistor, the 3904, what is the power dissipation maximum? 500 milliwatts. If I had a transistor like this in this circuit, it can handle 500 milliwatts of power. Where am I? 22.9 milliwatts. Am I pretty safe? The power is not as much as 500. It's not even 100. It is about 1/4 of 100. So that transistor is pretty safe. It's not going to be getting too hot. Okay? So that's what that value is. So that's the calculation that we're going to build these kind of circuits in our lab this week. So let's look at the second circuit on page 12.